Já, góðan daginn. Velkomin á þennan Azure Machine Learning fyrirlestur. Við erum með hérna Heini Ilmarinn sem Microsoft MVP og ætlar að fara aðeins yfir Azure Machine Learning með okkur og við bara vonum að þetta eftir að nýtast okkur vel. Þannig að ég segi bara gangi henni vel. Heini, welcome. I will just give you the word now. And good luck.
Thank you. Good day, everyone. Greetings from Finland today, and I'm here to talk to you about Azure Machine Learning today. And so let me just get the share going and we can begin. All right, so today what we will be doing is looking at Azure Machine Learning and kind of going through the range of how do you get started with like kind of the easy visual tools that we have available within Azure Machine Learning and how you move through from there and on to actually using notebooks. So we'll kind of go through the range of what are your options and how Azure Machine Learning works and how you can take your first steps there. And so if you have any questions during the session at any point, just feel free to toss them in the chat. I'm today stuck on one screen, so I might not see them right away, but I'll leave some time to the very end to cover the questions that we might have. And if there's anything relevant along the way, obviously feel free to just tell me that there's some questions and we can also pause and take them in the middle.
Yeah. Sure.
All right, so let's get started here. So really why we are interested about machine learning. It has to do with the fact that we have some kind of data. It doesn't really matter what the format is. It can be some kind of streaming data. It can be photos and videos, etc. It can be even relational data or either less or more structured. But anyways, we're interested in our data. And with machine learning particularly, we're interested in finding out whether or not we can predict something based on the data that we have. And that way also kind of reduce unnecessary work or adjustments or whatever we need to be predicting. And so whenever we have some data that we start with, we first need to kind of take care that that data is actually of good quality. So we need to do some cleaning and prepping. But then the essential thing after that is to be able to train some kind of machine learning model that will then be able to do the predictions. And based on this training and getting that algorithm out of there, our point is to be able to gain some insights and to be able to have those predictions in place. And so from Azure Machine Learning point of view, what we have kind of as the most easy way to start is the designer. Because this is actually a nice graphical interface. We can just drag and drop tasks, put them together, link them together, what happens first. And it's kind of very self-explanatory. We just need to understand the process first and how we kind of tie everything together. But we can kind of easily build a full trained model using the designer. And so to get started is actually nowadays quite easy. It's easy in the sense that we don't first have to get a mathematics degree to get started with machine learning. It is also super fast. We don't need to also learn coding. We don't need to know Python. We can just use these pre-built tasks that we have within Azure Machine Learning. And as said, we are not gonna need even one line of code to get any of this done. But we also need to understand when we use the designer, what are the restrictions and what are the limitations, and understand when we need to, for example, move to using notebooks. And that is what I will be attempting to portray to you today. So I'm Heini Ilmarinen from Finland. I work as a DevOps consultant at Polar Squad currently. And so I look at many problems from the architectural point of view, even though I do DevOps as well on the Azure side, but I kind of take an architectural twist to everything. I'm also a Microsoft certified trainer, so I run some Azure trainings on the side as well. And I actually have a mathematics degree, even though you don't need it for machine learning, but that's what I studied before I stepped into the IT. So I'm a bit of a math nerd at heart, and this session is one of my favorites because I get to kind of combine all my past skills with what I do today with Azure. And as you might have already noticed, I'm a bit of a serial doodler, and that's kind of what we'll be using along the way. Plus doing quite a bit of hands-on stuff in the machine learning studio as well. So we're first gonna get started with the designer. So that is where we are going to begin our journey today. And before we hop into the machine learning studio, I just want to kind of lay the foundation of what are our options to working with machine learning in the Azure Machine Learning service. So we actually have 3 different methods. So within Azure Machine Learning, we have first the designer, as mentioned. This is the easy drag and drop tool where we have that nice graphical interface. We don't need to code. But of course, we have to always be in Azure Machine Learning itself, because that is a kind of a functionality of the studio. It is built as part of that. But on the other hand, we also have something called notebooks. And for the notebooks, we can write them in Python or R or anything like that. And that will be kind of the second portion of this talk today. And then as the last portion, there is automated machine learning or AutoML. And this is something we won't be covering today, but you can kind of run these from your notebooks, and the auto machine learning helps you kind of do exploration on your data and test around what kind of algorithms would be suitable. So it will kind of run through many different options on one go for you. Excuse me. All right, so we're gonna get started with the designer first. We're going to hop into the Azure portal. I have actually created an Azure Machine Learning service already beforehand in Azure. And to start working with it, it will actually direct us to a separate studio. So we are going to launch the studio here and start working from here. And I'm just going to make this a little bigger. There we go. Will be easier for you to see. So right after we navigate into the studio, we kind of see those 3 options here that I was talking about. We have the notebooks, we have the automated machine learning, and we have the designer that we can use. And we're actually going to get started with the designer. And we're just going to start with a fresh pipeline here. So that's what the designer experiments are called. They're called pipelines. And we're just going to use that one. And right away, when I navigate here, it's going to ask me some basic things. It's going to ask me to select a compute target. I happen to have already one compute target here, and it has been successfully provisioned, and we're just going to choose that one. I can also set some pipeline parameters and default output settings. And then we also need a name for this, and I'm just going to name Iceland Azure Designer. And that's it. That's all we need. And this has autosave on it, so whatever changes we make, they are already saved. And so we have this canvas that we're working with, and on the left here we have these tasks that we can pick. And of course, in the beginning, to start working with something, we need a data set. We need to have some kind of data. So of course, in your scenario, you would have your own data set from somewhere. I am using one of these open data sets that are available, and this particular one has diabetes data in it. So once I have dragged the data set here, I am actually going to be able to visualize this data. So I'm able to click, and it will kind of load this visualization of data where I will see kind of some examples of the data. What is it like? And how is it also distributed? So by choosing one of these columns, I'm able to see some of the average values, so the mean and median, and also the minimum and maximum values, and also the standard deviation. So, for example, in the age column, we have people between the ages of 19 and 75. And then we can kind of see how the data is distributed between these different values. And we could go through all these columns and kind of check whether we have any empty values or anything like that. So we can find that directly in these kind of measures for each column. So these come out of the box. So it makes really checking your data for its validity, etc. It makes it really easy. But even when we look at this data set, we can see that we have quite many columns, but not all of them are very well named. So if we look at this, we see that there are these columns called S1, S2, etc. And we might not know what these mean. So really, in the beginning, we need to understand the data that we're working with. In this particular data set, these values from S1 to S6, these are certain blood measurements that can be measured that affect the chance to get diabetes. And so I'm not a medical professional, so I probably don't have the right amount of knowledge to interpret this. So oftentimes we will need some really core knowledge about the data that we're working with as well. And within this data set, we have this Y column over here, which is what is a value, numerical value that will tell the likelihood of somebody having diabetes. And the higher the value, the more likely it is, and the lower the value, the less likely it is. So this is kind of the column that we want to be predicting. And then we have all these other columns that we can use then to kind of as the factors for how we determine the algorithm. So we can use all these columns over here for that purpose. So now we have some general understanding of the data. In most cases, we want to start with first doing some cleaning of the data. So we could, for example, select certain columns if we knew that, well, we're just interested of the 2 blood values from the data set, for example. Or we could, for example, also handle missing values in different ways. And we can find all those tasks from the designer. So we can find, for example, steps for data transformation. So we can add columns or add rows, even apply mathematical operations, etc. So we have many, many values here, or many tasks that we can do. So for just one example, let's grab the select columns in dataset. So we're just going to grab that. And whenever we grab one of these tasks, it has kind of this section that we can edit. So we can edit which columns we want. And in this case, we could, for example, grab all the columns and then exclude one of the columns. So we could, for example, say we don't want the S3 column, for example. So we just save that, and now that is going to do this transformation to our data. And that's all we have to do here. Then whenever we're training an algorithm, we need to do a split to the data. So we need to have a training data set, and we need to have a data set that we use then to evaluate the model as well. So we're going to split the data. And in this one, it's going to determine the number of rows that will be in the first output database. I'm just going to specify 0.7. So that means that 70% of the rows is going to be in the first dataset. So that's what it means. And again, we're just going to connect these boxes together. So pretty much it's telling that this output from the previous step is going to be the input to the next step. So we're going to split our data. So that means we will be ready to train our data. Train model. There we go. And into this training, we are going to specify what is our label column. So this means what is the column that we want to predict. So that will be the Y column. And again, this means to determine this, we need to have knowledge of our data. So that's it. And again, now we're going to grab the first data set. We want to have the first 70% or the 70% of the data to come into the training. So now you might have noticed that in this train model step, we're not actually specifying what kind of model we're using. So we need to do that separately. So if we look at this, it's saying, well, we want in an untrained model. So it's telling right here that we need an untrained model here. And so for this particular case, we're going to choose the linear regression. Just another kind of area of the machine learning field is really understanding the different algorithms and what they can do. So with this data set, we're going to choose this one, but you need to become familiar with the different options and know in which situations to choose which one. So we're just going to stick with the default values. It's going to use the ordinary least squares method for the linear regressions. There is a lot of other methods as well that work a little differently. And again, you need to understand when to choose which one. And so we see the output of this is the untrained model, and we will drag that into the trained model phase. Once we have trained the model, we need to evaluate it. So this will evaluate the results of a classification or regression model with standard metrics. So it also gives a description. And for this one, we're going to grab the trained model. Oops, I think I got these in the wrong order. We're going to also need the score model first. Sorry. So I got those in the wrong order. So we're going to grab the trained model and give that into the score model. So what the scoring of the model means that it's gonna take the values that it got from the training and the algorithm, and then it's going to check against the other branch of the split data, what kind of results it gets from there. So it's gonna use that trained model that we just created and use that to score the evaluation data. And then based on this, we're then going to be able to evaluate the model. So the evaluation then will tell us how well did we actually fit this model into the data set that we have. So, all right, here we have our first pipeline. So our very first experiment in Azure Machine Learning using the designer. So what we're going to do now is we're gonna say submit, and in this phase it's going to tell us to choose an experiment. We're going to need a new one. I'm just going to grab that one as the experiment name. Oops, but we're not gonna. There we go. And it's going to use the default compute target there that I had created before. So we're just going to submit this pipeline, and then we just have to wait. On the first run, it does take some time because the nodes that were, for example, on my compute, there weren't any available when I chose that. So it has to first put up the compute nodes, and then it will run this training. So we're not going to wait for it because it's going to take a little bit time for it to be ready. We're going to move on a little bit and check back on it in just a moment. All right. We have gotten started quite quickly with the designer. It took us about 15 minutes to build that first pipeline and get running with the first experiment. And so as the next step, we are going to get an overview of Azure Machine Learning, because we heard a lot of terminology while we were working with the designer about experiments and compute and all those things. And also, if we're thinking about then moving on to using notebooks, it's really relevant to understand all this different terminology that is relevant with Azure Machine Learning. So we're going to do a brief overview of what are the components and what do we need to understand before we can be using notebooks. So as said before, we have these three different methods that we can work with. We have the designer, the notebooks, and the automated machine learning as our options. So those are the different ways in which we can train our models and so forth. And so whenever we're working with these, we first need to have some kind of data. And within Azure Machine Learning, we can actually configure data sets and data stores. So the data stores are what will point to a specific service that has data. So for example, it can point to an Azure Machine Learning, it can point to Azure Storage, it can point to some online location wherever. And then from that data store, you can find multiple different data sets. For the data sets, you can define them from a particular data store, or you could just have kind of public data sets that you want to use, like the open data set that we were using. But while you're using, for example, the designer or let's say the notebooks, you can connect to also data sets that are not defined within Azure Machine Learning. But by defining these data sets in Azure Machine Learning, you enable that these are available to all the users who are using the data from within Azure Machine Learning. So really you can have kind of these standard sets of data that then multiple people can be working on and finding the relevant information for your business. So we start with some kind of data. And then we have our designer or notebook experiment. And when we want to really be running that, whether we run it manually, whether we run it automatically, we need to have that connected to some kind of compute. It's going to need some kind of compute power behind the scenes to be able to run that training experiment. And so for those compute options, we'll kind of take a closer look at it in a minute, but you notice that I created chose a compute when we started to run the designer. But also when we're running our notebooks, we need to have that notebook connected to a compute that has all the relevant tools that it uses. And the same with auto machine learning as well. And as the last portion is the phase where we actually want to run that is where we have the experiment coming. So that is what it was asking us to create when we were starting to run or submit our designer pipeline. So really, that experiment will then hold all the different runs that we've done for that particular pipeline or a notebook. We can kind of go back and look at the previous runs that we've also done at that end. So if we just go one back, so we have kind of this full-on structure where we have the data sets can be defined elsewhere. We can have the standard compute nodes that we can use in different scenarios. And then for one specific notebook or a designer pipeline, we would have a specific experiment as well. So those are the main core terminology that we need to be familiar with. And so this is still running, we'll let it run, and while we kind of wait for that, we're going to poke around a bit what we have available. So we can see quite a bit of those terminologies that we talked about here on the left, and we can navigate to these. So we talked about the data stores. This is where we can define different kind of services where we might have some of our data. So for example, there is this global data sets for Azure Machine Learning that we can use. So these are kind of standard example data sets that we can use. But also if we have our own Azure SQL or Azure Data Lake or anything like that, we can also register that as a data store here in Azure Machine Learning. The other portion of this is the data sets. This is where we are pointing to a particular table or a particular file within our storage. So for example, this is the data set we were working with in the designer, the open data set diabetes 1. And so we can create a data set from here. We can just pull in local files if we want to get started really fast. We can define one based on a data store, or we can use the web files. And one of these really kind of useful sources is these open data sets that I was working with, diabetes one, this one here. There are quite many different data sets available here that you can start working with and test different algorithms and things like that on these. So it's kind of easy to have a well-defined data set in the beginning when you're getting familiar with the tool. So that's where we can do that. And this is where we can also see this one. And we can find that it's actually pointing to Azure Blob Storage. And there's this diabetes folder with a bunch of Parquet files there that we're using in this particular version. Then we have the compute side, which is down here. This is where we have our different compute instances running. I have already created a compute instance for the notebooks section of this talk as well, which we will be using in a moment. So this is a single compute instance, so not a cluster, just a single compute instance. And it has several applications running on it, so Jupyter and VS Code and RStudio and so forth. So the tools that you would need to be working essentially on notebooks, even from your local device as well. So all the relevant applications are already installed there. On the compute cluster side, this is what we ran our designer experiment on. So it is a cluster, there are multiple nodes. 2 in this case. When you create this, you specify what size they are. This might actually be quite small for this use case, especially if you go to like more real-life scenarios. You might need some bigger nodes there. And as you can see, right now there are 2 busy nodes since they are running the designer experiment right now. So those are our 2 main compute types that we can use. Then the last portion that we talked about is the experiments. So right here you can see that I have some old experiments here as well. We could go back to an old one and see, for example, this one has 20 completed runs, and then we could kind of go through the different ones and see what has happened with all the different runs, experiment runs that have been run in the past. So there are also some other areas here that we didn't discuss in so much detail, but for example, there is the model section where you can then register once you are done with the training of your model and you're ready to kind of bring it live. There's this model registry within Azure Machine Learning that you can then use to deploy those models. And then there is this endpoint section if you're using to turn your designer pipelines into kind of endpoints that you can call from your applications. Those would end up over here. So there's the general overview. Let's pop into our designer and see whether it would be done or whether we need to give it a little more time. It needs a little more time. As said, the first run is always a bit tedious to be waiting on. After that, the consecutive runs after that are much faster. So it is getting done with the select columns, and then after that it will move on to the following steps. But we'll let that keep running and we'll keep checking in on it and see at what point we can look at the results. And in the meanwhile, we are going to return here and understand that, yes, we have a general overview of Azure Machine Learning. Know that there's a little more detail to it and you can find out more, but you kind of have the main pieces in place. And we have now enough information that we can start working with our first notebook. So really getting started with what do we need to be running notebooks, what happens when we run notebooks, etc. We'll kind of walk through all the different phases and how they also relate to the designer. Can we kind of do a compare contrast situation, or how should we think about them? So we'll navigate back into the Azure Machine Learning Studio. And we have this notebook section here on the left. I have created a notebook beforehand, so we can really focus on what is each of these pieces doing and understanding them. And then kind of also we are able to compare to what is the difference compared to the designer and what kind of extra steps we have here that we need to take care of. So we're going to start with connecting to Azure Machine Learning Workspace. So pretty much, if you look at this, you would be able to run this notebook from your local machine as well, from your laptop, as long as you have the required SDKs in place. So you would need, for Azure Machine Learning notebooks, we have both the R SDK and the Python SDK available. And then you need to have the relevant Azure Machine Learning specific libraries as well. So whenever you're working with notebooks, you will notice that within each of these steps, we are using a lot of these pre-built libraries. So the coding itself isn't very complex, but a lot of times we need to know which libraries to use. And that can, if you haven't used notebooks before, it can be a little weird in a way. It can seem a little, okay, what's happening? And also within the notebooks, there's the aspect that you can both have these just documentation blocks almost. So you write them in this markdown format, and then it's able to turn the first row into a title, etc. And then you can have these code blocks. So really you could combine both your documentation of what are the steps and also then the code blocks that need to be run. So as the first step, we're going to just get the workspace configuration that we want to work with and do interactive authentication. And with some more specifications, you could even connect to a different Azure Machine Learning workspace than the one that we're working on right here, if you wanted to. Then in this case, previously when we were running in the designer, it would ask us for the experiment when we were ready to run this, but as we're kind of running this on the go, we also need to create a new experiment or connect to an existing one from this notebook. And so let's make this like that. Let's run that. And as you can see, it's able to run these blocks very fast. So that experiment has now been created. Then we're going to get the data set. There is a library that allows us to fetch the open data sets directly. We could also use kind of the information of the data set within the Azure Machine Learning definition to connect to it as well. And what we're going to do in this particular step is grab that diabetes data with the get tabular data set, and then put that into a data frame. So we're gonna translate that into a data frame. And that is a very common way that we work with our data sets in Azure Machine Learning. So we're going to run that. And for some reason, this remembers. I'm gonna do a little clearing off the blocks. I thought I did that. Apparently not. I'm going to clear all the outputs. I'm just gonna run through these top ones real fast. Just that we have everything set up right. And now that we have the diabetes data in a data frame, then we're being able to use these functionalities of looking into the information of the data frames. So we have the info, which we can use to just get a general sense of what are our columns like. So we get the different data types. We see that there are 442 values on each of them. and there is also 442 entries. So we know that there are no empty values there. And then we can see that we have some integers and also some decimal numbers. So the floats are the decimal numbers. If we want more information about this data, we can then run the describe. And this will show us a bit of that similar information that we were able to see for the data when we chose the visualize in the designer. So we were able to see the mean values. We also saw the standard deviations, the minimums and maximums. But here we're also seeing the 25 percentile, the 50 and the 75 as well. So we see some similar information and some different information. We don't get a nice graph quite using these methods, just they describe, but there are ways to make visualizations of your data, but we're not going to go into that today. So we're going to move on to the next one here, which is where we're going to do the splitting of the data. So we're going to split the data into two. So we're going to create an X data frame and we're going to create a Y data frame. And we're just into the X data frame, we're going to take all the data, the diabetes data frame, and then we're going to create the Y data frame by taking the X data frame and taking the Y out of there and putting it into the Y data frame. So essentially we're taking the Y out of the X data frame and putting it into the Y one instead. Okay, there we go. So it has now split those, and if we want to confirm that this has actually happened, we have two different data sets. We can just run the describe again for the X, and we can scroll and see that we no longer have the Y. And if we run the Y data frame, we notice that we actually have that Y column from the previous step. So that was part of the splitting of the data, but we need to do one more thing to really split it into the training and testing data. So again, we're going to use a library. In this case, we're gonna use the scikit-learn library, and this is one of the libraries that is most used for machine learning. Within here, we have, for example, the model selection. We can have different kind of models that we can use, and we have metrics once we have trained the data as well. So you will see that we're using different libraries from there, from the scikit-learn library in the next few phases. So we're first going to use the train test split to really do the final splitting of the data into the training and testing data set. And how we're going to do it, we have kind of this pre-made algorithm for it. It will create these 4 data sets, and it will take in the X data frame, the Y data frame, and then the test size here is 0.3, because here we're specifying how big is the test data set, and we want that to be 30%. In the designer, we specified what is the size of the first data set, and we used the first data set for our training, so we wanted that to be 70%. So here we're determining the second data set size essentially here. So we want that to be 0.3. And then we also added this random state to how it does the splitting. We actually didn't use that when we were building the designer, but it has also that random state that you can put in. So we're going to run that. It split the data, and then we're going to go into choosing and training our model. So in this particular case, we're going to grab the linear model options, and we're going to use the linear regression from there. And we're just putting that into a variable called regress, not the best name for a variable. And then we're taking the X training set and the Y training set and using that to fit our data. So remember, our X training set now includes all the columns that we're using to train this model, and Y includes what we're trying to predict. So that's kind of the difference that we're doing here in the notebook compared to the designer, there you just had to specify once what are you predicting, and it handled everything else behind the scenes. Here we need to kind of always keep in mind, okay, we have the columns that we're using for training, which is this one, X-train, and then we have the column that we're using for the predicting, so that is the Y-train. So that's why we have those two portions. And the X-train does contain all of those columns that we're using for training. And if you're looking for more information on machine learning and how that works, that is actually a matrix. And you need to kind of understand a bit of matrix calculation if you want to look behind the scenes and understand how everything happens. Then that is a part of mathematics that you can look into. But with this one, the nice side is we don't have to actually do that linear algebra calculations with matrices by hand or even by calculators, but these libraries that we can use here take care of all of that for us. So that's actually really nice and makes it really easy to run these. So we're doing the training or the fitting of the model, which it's called here on the code side, and then we are going to use the test data set to predict from that, and we will get a prediction for each of the values from the dataset that we're using to test. So we're just gonna run that block. So we both pick the linear model we used it for training, and then we did the scoring in the designer. And so as the last part, we need to do some evaluation on this. So we're going to use just some standard methods for doing that. So we get the coefficients, and then we get something called a mean squared error. So what is the square of how far away we're from the right values? And then we get a coefficient of determination, which then kind of is also one particular one we can use to determine whether this is a good evaluation or not. So we get 0.52 for that. So we have run our notebook. An end result of this is a trained model that we can use, and it is kind of the similar. We have now run through the steps that we also took in the designer. And if we just go into the designer, because our run went through, we got a notification. We can kind of check and compare here as well. We have the very similar steps here as we took in the notebook. We split the data, we chose the model, we trained the model, we scored the model, and then we evaluated the model. Here on the designer side, it is a little easier to do a lot of these visualizations. So we can, for example, look at the score model result visualization. And here we have the column that we were trying to predict, so the Y. And then the scored labels are what the model predicted for each of these rows. So for example, the real value was 199, but we evaluated that it would be 112. The real value was 107, and what we evaluated was 179 roughly. So you can see some of these values are quite close to the real values, and some of them are quite far away. So there's some variability to that. And of course, we need to understand what kind of range is this? What is this Y actually telling to understand whether a difference between 199 and 112 is actually a big difference in this case. So we need to understand the data again to really determine that. But then we also have this evaluate model phase. And here we are able to then check also a visualization. And this is going to give us some of those values for determining whether this is a good model or not. And here we can see, for example, we have a little bit of different metrics here than in the notebook. So for example, in the notebook, we had the mean squared error. Here we have the root mean squared error. So if we did have taken a root of the mean squared error that we had in the notebook, we would also land between 50 and 55 there as well. So we're very close to these results. And then here we have the coefficient of determination that we had in the notebook as well, and with that one we are also very close to that result. So pretty much I did the splitting of data a little differently. I didn't have the random factor here in the designer, so the results are not exactly the same, but they're quite close to each other in this case. So we have been able to build a kind of a designer pipeline, as well as create a notebook that was run against a computer cluster as well. And so here we can see all the different experiments. We haven't kind of run this officially yet. We were, of course, running it as part of the notebook and going block by block, but we haven't really kind of triggered this in a full way, the notebook that we created. So we've now, if we really think about the designer and the notebook, what we can do when we're trying to go from a designer experiment to a notebook, we can kind of use the designer to get familiar with the different steps that we're going to need. And then we can think about, once we understand each of the steps, we can kind of take one of those steps and then think about how would we implement that in the notebook. So for example, for the splitting of the data, we have to do kind of two phases in the notebooks. We first have to create these two separate data frames. So the data frame that we use for predicting and the data frame for the column that we are predicting. So to do that, we use the different data frame functions. So we use the pop that took the Y column from the X data frame to the Y data frame. And then as the second portion, we had to use the train test split to really have those training and testing data sets for both the columns that we're using for training, predicting, and the column that we are actually predicting. So there's kind of these two different phases to it compared to what we did in the designer. There we just had to say split data, give it the percentage or that in decimal format, and then in one of the steps we told what are we predicting, and then it took care of all of this on the background. So some things are simpler to do in the notebooks and some things are simpler to do in the designer. If you noticed with the notebooks, all of the runs in this case with this data set were very, very fast. It just took like 1 or 2 seconds or something like that with each of these. So like the performance is really good on the notebooks, and compared, I would say generally the designer is slower than the notebook version. And the other side to the designer where we have restrictions is that, for example, for the linear regression, we have 2 different methods that we can use. But from the Scikit library, we have multiple different methods that we can do linear regression in. And oftentimes, yes, the most common methods are available in the designer, but not all of them. And also, sometimes you might need something more elaborate. And that is why you would not then, for example, want to go with a designer only. So what we've been doing now is we started quickly with a designer. We created a pipeline there. Then we took an overview of Azure Machine Learning, and then we wrote our first notebook. So when you're starting to consider about working with your data and bringing it in with Azure Machine Learning, yes, we still need to do the cleanup and the preparation, but we can do that as part of either the designer or the notebooks. And when we start to do the training, again, now that you've kind of seen a walkthrough of both of these options, you are definitely able to draw your insights either using the designer or also using notebooks. So you have both options. So I hope I got you intrigued and excited about Azure Machine Learning and kind of feeling that, yeah, I can get started even with the notebook side and just start working piece by piece and really building your first notebooks there as well. So thank you for joining. I hope you enjoyed it. If you want to connect or have any questions you don't have time to ask here, feel free to reach out to me on Twitter. And thank you so much for joining. And I'm going to check if we have any questions here.
Yeah, we have a few.
Okay, great.
So I should just ask them and you can answer them.
Yeah.
There is actually just one user just spamming here questions. Is there possible to connect to an API, and how does that work with an authentication?
So yes, if you have an API that returns, for example, JSON or something like that, and it's a URL, yes, you can do that. I believe currently the machine learning datasets don't support authentication that well. So you might need to do kind of fetching of the data and import it to, for example, your storage account in Azure and then use it from there. So I'm not 100% on the authentication side. If I remember correctly, it's not really supported currently. So it's kind of those like freely accessible data sets you might have on the internet are kind of the target, unless you're using your own data set. Then you have options to connect with Azure SQL, Azure Storage, whatever you might like.
So there's basically, I think, a follow-up question on that. When connecting to a data set, is that a streamed data or does it take a snapshot at a certain time?
So that is definitely a snapshot. So it doesn't directly support streaming. Again, you kind of have to have the stream handling done in your own end. So really a lot of times to use machine learning, we need to have some kind of data platform behind the scenes where we have all our data handling and, you know, integration, how we're bringing data in, how are we handling our streaming data. All that needs to be on the background. And then we are able to plug in with Azure Machine Learning to that data. Then if we're kind of thinking about an application that handles streaming data, you can have an application that takes in streaming data and then gives that streaming data to already trained machine learning algorithm and kind of gets some kind of prediction out of that. So then we kind of get to the side of machine learning of how do you really productize this? How do you bring it to production and how do you run the model in real life as part of your application? But that is very much a topic of another session. And I think I need to create that because I always get these questions about like, how do you then work with it like in production as part of your application?
Yeah. So there's a kind of different question here related to infrastructure management. How is it possible to use this, or do you have any examples on how this is used in infrastructure management?
I haven't personally done that, but yeah, I definitely could. I think there would be a lot of value in using machine learning with infrastructure management data. And because we could start learning about different patterns that are for certain workloads, for example, and then if we kind of start to see the workload pattern going up over time, we would know that, well, actually now we're gonna need to add resources or something like that. So definitely, that's actually a really good idea. And I'm sure someone has implemented those as well.
Mm-hmm. The last question here is, do you have any details or ideas if there are any governments using Azure ML to enhance their service?
I know Microsoft even has some examples of use cases on their website. I also believe that in Finland we have one of the hospital services for certain, I think even during the COVID time, they used this data in Azure Machine Learning to do some predictions. But unfortunately, I don't have more exact information than that. But yeah, there are so many ways in which this could be leveraged. But a lot of times it, of course, starts with ensuring that you have quality data, that it has all the information that we need. It's not missing huge chunks, and it's actually in the format that we need to then build the model. But yeah, I would suggest go poking around some of the Microsoft use cases. Those are good, and you can probably even find use case examples from other companies that have implemented them using Azure Machine Learning as well.
Okay. So this was the last question. So
perfect.
If there aren't any more, so then I think we're just finished. This is very nice, very informative. The government is actually having a competition on how we can utilize machine learning and AI in governmental issues. So that was probably a relative question to that.
Oh yes. Yeah.
So,
actually, what came to my mind, I have heard about like cases where they've done things around waste management, for example, how to empty the trash, etc. Very, a very exciting topic, but it's relevant. That has been done. I know there's a few things around health data, as I mentioned, etc. And yeah.
So there are a lot of interest in machine learning right now. So there were a lot of people watching this. So that
Great.
was very nice. If there is anything else, then I would just like to thank you very much for this.
You're welcome.
It was very, very informative, and we were very happy with this. At least I was.
Yeah, so, great. Thank you for having me again. It was a pleasure.
Yeah. Maybe sometime you will come to Iceland, and
yes,
we will walk to the volcano. As you know, there is a volcano just outside Reykjavik.
Yeah.
So thank you very much.
Thank you.
Good luck.
Thanks. See you.
Bye-bye.
Bye.